let's go back and look at the graph of the sine function, okay? This is a function that you should know by now. So let's recall the graph. Okay, here's our nice sine x function. Remember, the sine of 0 is 0, sine of pi halves is 1, sine of pi is 0, etc. We got this nice smooth curve. Now notice, this is not a one-to-one function. It really fails the horizontal line test. So what we want to do is we want to restrict the domain. We want to chop off part of the sine function and try to make this a one-to-one function. Okay? Well, notice, if I only wanted to talk about the sine function from here, that would be minus pi halves to pi halves, and I only graphed that, it would become a one-to-one function. Okay? If I got rid of everything except this little portion here, that's definitely a one-to-one function. Okay? So, let me read this to you. Obviously, sine x is not a one-to-one function because the graph fails the horizontal line test. However, if we restrict the domain of the function, we can make it a one-to-one function. And that's what I did. I'm only going to talk about this little portion. And that little portion certainly does pass the horizontal line test. So, let's let f of x equal sine x for x in between minus pi halves and pi halves. This function is a one-to-one function, and therefore it has an inverse. So let's take a look at my new function. I'm going to just graph the blue part that I've designated here, and there it is. I've chopped off everything else. Now notice this function now does pass the horizontal line test. So this function is one-to-one. Okay? Now, remember, every one-to-one function has what's called an inverse function. Therefore, this little graph here must have an inverse function. So let's define it. If f of x equals sine x on this restricted domain, then we're going to define the inverse function as f inverse of x is equal to sine inverse of x. I'll also refer to it as the arc sine. These two things are synonymous. Okay? F inverse is equal to sine inverse. Note, sine inverse of x has nothing to do with sine x to the negative 1 power. These two things are not the same. This is just notation. Okay? So whenever we see this, this is called the inverse, not 1 over sine. It's very important that you know that. Okay? All right. So let's try to figure out what the graph of this thing is going to look like. Well, first of all, note that the domain of this function is negative pi halves to pi halves, and the range of this function is negative 1 to 1. Therefore, the inverse function must have domain negative 1 to 1 and range negative pi halves to pi halves. And it looks something like this. Okay? Where this point here is negative pi halves to pi halves, and the domain is negative 1 to 1. There is our inverse function. Okay? So let's write this down. First of all, we're only going to talk about sine x as a one-to-one function right now. So if sine x is 1 to 1, we're going to restrict the domain to negative pi halves to pi halves. The range is going to be from minus 1 to 1. Then we're going to define the inverse function as sine inverse or arc sine. They mean the same thing. And it's going to have domain negative 1 to 1 and range negative pi halves to pi halves. And the important thing is that we know what this function means. Okay? We're going to define the inverse sine as the angle on the interval negative pi halves to pi halves whose sine is x. Now write that down. Okay, and I'll repeat it again. The arc sine, or the inverse sine, is the angle, okay, on the interval minus pi halves to pi halves whose sine is x. So whenever we see these arc functions, we'll do arc cosine and arc tangent also, they're actually angles. So in the past, we're used to putting in an angle into the sine and it will spit out a number. Okay? Now we're going to put in the number and it's going to spit out an angle. So for example, let's figure out what the arc sine of 1/2 is. So we want to figure out what is the angle between negative pi halves and pi halves. So maybe I'll draw a little circle here. There's the angle negative pi halves. There's the angle pi halves. So I'm looking for an angle in between here such that the sine of that angle is 1/2, or the opposite over hypotenuse is 1/2. That must be here. If I look at a circle with radius 2, let's see, square root 3 would go there. So I'm looking for, what is that angle? What is the angle whose sine is 1/2? Well, that's one of our special right triangles, and that's a pi/6 angle. So the arc sine of 1/2 is pi/6, okay? Because the sine of pi/6 is 1/2. Okay, these are very tricky, so I'll do several. All right. Let's figure out what the arc sine, or the sine inverse, of negative square root 3/2 is. Again, the easiest thing, I think, is to draw a little circle. Remember from the definition of arc sine, it's the angle in between negative pi halves and pi halves, whose sine is the square root of 3/2, negative square root of 3/2. So that means it's got to be in this quadrant here, right? Because that's the only quadrant on this interval that's going to give me negative values. So I'm looking for the angle theta, whose opposite over hypotenuse is negative root 3/2. And of course, this must be a 1. It's another one of our special right triangles. So theta must be a pi-thirds angle, okay, because the pi-thirds is always opposite the square root of 3. But since we're in the clockwise direction, that's going to be a negative angle. So theta must equal negative pi-thirds. So the arc sine of negative square root 3/2 is negative pi-thirds. Okay. Okay, let's go back. Remember property 3 of inverse functions that we talked about in a previous lesson? If we compose them, we always get x. F composed of f inverse is x for all x in the domain of f inverse. F inverse composed of f of x is x for all x in the domain of f. So the following must be true. I'm just going to call f sine x, and I'll call f inverse arc sine x. So sine of sine inverse is equal to x. I'm just writing this again, but I know what my functions are this time. For all x in the domain of sine inverse, and sine inverse composed of sine x is equal to x for all x in the domain of sine. Let's do these. All right. The arc sine of sine pi/6, well, that's just pi/6. Since pi/6 is in the domain, remember, any number between minus pi halves and pi halves is in the domain. So arc sine of sine pi/6 is just pi/6. Okay? Sine of the arc sine of 1/√2 is 1/√2. Since 1/√2, that's definitely in between minus 1 and 1. Remember, the domain of the arc sine is all numbers between minus 1 and 1, and this is definitely a fraction between minus 1 and 1. And last, let's look at this one. Arc sine of sine of 2 pi over 3. That's not 2 pi over 3. Remember, what the sine function looked like? Okay, there's our sine function that's 1 to 1. Notice 2 pi over 3 somewhere out here. 2 pi over 3 is not in the domain of sine, so we cannot say this is true. So we still want to figure out what this is. Okay? So let's see. The first thing I want to do is figure out what is the sine of 2 pi over 3. Let's see. 2 pi over 3 is somewhere over here. Okay? And I'm just using the knowledge that we've gained throughout this course. There's an angle of 2 pi thirds. That means that's an angle of pi thirds there. So I get square root 3, negative 1, 2. So the sine of 2 pi over 3 is square root of 3 over 2. Okay? So we couldn't just say this is true because 2 pi thirds is not in the domain of our 1-to-1 function. So I figured out what the sine of 2 pi over 3. Now, what is the angle whose sine is square root of 3 over 2? What is the angle between negative pi halves and pi halves whose sine is square root of 3 over 2? And then I'll be done. So let me draw a picture. Another circle. There's negative pi halves. There's a pi halves angle. Let's figure out what is the angle in between here, whose sine, or whose opposite over hypotenuse is root 3 over 2. Well, that must be a pi thirds angle. So the arc sine of square root of 3 over 2 is pi over 3. Now this is very tricky stuff. You might want to review this lecture a couple times. Okay? Certainly come by the Polya Math Center if you need some help, or come by your instructor's office hours and they'll help you as well.